All right, so this is lesson 3, using synthetic division to divide polynomials through. So synthetic division is just a cool shortcut instead of having to do everything by long division. To be honest, I'm a long division guy because I make less mistakes using long division than synthetic division. But here's the long division work. Here's the synthetic division work. You can't argue that this is substantially smaller than that. It's also faster, which just makes it more efficient. So, in general, this 2 on the left side is like that. This 3, 0, negative 7, 9, so this is the root of the divisor. There we go. That's the divisor, the thing you're dividing by. And it's the root, it's the 0 of that factor. These numbers are the coefficients of the original polynomial. The 1 is the remainder, and these are the coefficients in the bottom row of the solution. Cool, we just discovered it. Now, instead of trying to figure it out, we're just going to jump straight in. So what I do if I'm doing synthetic division is I put the coefficients here along the top. I make my box big enough so that it has a second row. You don't need to make it huge. It's not like gigantic. It just needs to be able to accommodate one row of numbers below the coefficients. Now, this is where this book I like. This is the way that I've learned synthetic division in multiple other sources. However, it's not the way that the standard textbook does synthetic division. So don't go getting confused. What this book and most other synthetic division algorithms I've used do is that they don't use the coefficient of this thing. They use the 0 of this factor. So the 1 goes in here. Now the process is that this first 2 drops straight down. It's got nothing to add or subtract to. But now that we have a number down in this place, I take this 1 times that 2, and my answer goes up here at 2. Now instead of just dropping down, there's another number in the way here. So this negative 3 can't just drop down. Instead, what it does is we add negative 3 plus 2, and that gives me a negative 1 down here. Now, this is going to multiply by this negative 1. The answer goes up here. You don't need all these arrows, by the way, once you know what you're doing. It becomes much more efficient. Now, negative 8 plus negative 1 is negative 9. And then lastly, and do the same thing. 1 times negative 9 is negative 9. 15 plus negative 9 is 6. That goes up there, and this adds down. 15 plus negative 9 is, in fact, 6. So this is my thing. So my polynomial, 2x cubed minus 3x squared minus 8x plus 15, is equal, or divided by my divisor, sorry, x minus 1, is equal to my answer, which is all of this stuff. So I have to just reconstitute. I like talking about the fact that this answer isn't really the answer yet. It's like concentrated juice isn't really juice yet. We need to add the water. We need to reconstitute it. In this case, we need to add our x's back in. So I start here. This is your 1's term, your x's term, and your 2x's term. Does that make sense? Hopefully that makes sense. Anywho, this is going to be 2x squared minus x minus 9. So that's my quotient. Then my remainder is 6, and it's all over x minus 1. Ta-da! Done. Okay, let's do synthetic division here. If I were to work this thing through, it goes 5, negative 6, 3, oh, not 3. Look at me go. I need a 0 in here because it has no x cubed term. So 0, then 3. I wouldn't need the plus 3. I could just write 3. 3, negative 2, 1. And I'm going to be dividing in negative 2, right? Because that's the 0 of this factor. 5 drops down, negative 10, negative 16, adding, positive 32. Positive 32 again, because 0 plus 32 is just 32. Negative 30, or negative 2 times 32 should be negative 64. This gives me negative 61. Adding down, negative, yeah, I think that's right. That makes this positive 122, which makes this positive 120, which negative 2 times that is negative 239, which is also negative 239 here. Holy cramoles. Good. Now they want me to find the value of the polynomial when x is replaced by negative 2. So let's see how I can do on this. This will be a serious workout for McManus's mental math. Anywhom, 5 times negative 2 to the 5th minus 6 times negative 2 to the 4th plus 3 times negative 2 squared minus 2 times negative 2 plus 1. Okay. 2 to the 5th, 32. Negative 32, because it's negative 2. Negative 2 to the 5th, negative 32. Times 5. Negative 160. I'm mostly sure of that one. We'll see what it turns to in the end, and I'll fix it if I need to. Negative 2 to the 4th is 16. Positive 16, because it's an even exponent. Positive 16 times 6. 6 times 10 is 60. 6 times 6 is 36. So I think 96. I'm not entirely sure of that one either, but let's go with it. 2 squared is 4. 4 times 3 is 12. That one I can do pretty straightforward. Negative 2 by negative 2 is positive 4 plus 1. Let's try all that out. So, combining my negatives together, negative 160, this is going to be negative 256. Yeah, that looks good. And then plus 17. And, ooh, it worked. If I put negative 256 and 17 together, I get negative 239, which was miraculously supposed to be what I was going to get because they match. Hey, they match. This is something called remainder theorem. We're going to see it later. So right now, I'll just ignore it. Here we've got part of a synthetic division, so they've included some values that are variable. But anyway, I'm going to start with a negative 3 up front. Okay? My 2 drops down. Negative 3 times 2 is negative 6. Negative 6 there. Negative 4. Positive 12. And now I end up with this. Negative m plus 12 equals 2m. Mysterious. Maybe m for mystery. Anyway, let's combine our like terms, solve it. I'm going to throw those over there. 12 equals 3m. M equals 4. So really this is 8. And this is apparently negative 4. Now, negative 3 times 8 is going to be negative 24. So n is negative 24. Negative 24 plus 16 is negative 8. So apparently this is negative 8. So m is 4 and p is negative 8. I'm mostly sure I did that right. There's all sorts of places I could have made some sort of silly mistake. So see if you agree with me. And if not, let me know. Come bug me so I can fix it. There's another standard sort of style of question where you have to do your synthetic division given that the remainder is something. So I'm going to start by setting it up. 2, negative 4, a, 3. Got all 4 cubed, squared, linear, constant. Good. Negative 2 up front. 2 goes down. Negative 4, negative 8, 16. Now this is where it gets a little bit funky. What I'm going to do here is just go 16 plus a. I'm going to go negative 2 times this whole shebang is going to be negative 32 minus 2a. So hopefully that makes sense. Now, it turns out that the remainder is supposed to be 3. So I know this answer down here should be 3. So now I can go, okay, 3 plus negative 32 minus 2a. That's an ugly large bracket. There we go. Equals 3. That's handy dandy. 3 and 3. I subtract 3 from both sides. I'm good. Negative 32 equals 2a. So I just added my 2a to both sides. A equals negative 16. Solved. Now, that's the sort of standard stuff. There is a way of hacking synthetic division to incorporate these if you have a lead coefficient. I don't really like it. I find that it's a little bit more trouble than it's worth. For those of you who are really synthetic division aficionados, by all means, learn this. 93% of the time, exactly 93% of the time, you'll never even have to use this. The only time you'd have to use it is if you had multiple factors. I would factor out the other linear factors first, then end up with some quadratic that had a 2x minus 1 in it. But there are, I'm sure, some times where you might have to do this if you really wanted to. I would rather do it by long division, but we've already accepted that about McManus. So what we're going to do instead is, instead of dividing this out, what we do is we hack it. We turn it into that by dividing out the 2 or factoring out the 2. So I'm really going to do this division. So I'm going to put a positive 1/2 here. Hopefully that makes sense. 2 comes down. 1/2 times 2 is 1. 2. 1/2 times 2, 1 plus 1 is 2, right? So that's where the 2 came from. 1/2 times 2 is 1. This is going to give me 6. 1/2 times 6 is 3. 3 minus 1 is 2. So now, using my division algorithm, I could write this like this. There's my answer. 2x squared, 2x cubed, or 2x to the first, and 6. Okay? That's where that came from. And my remainder of 2, still there. Bonk. Okay. So now what we do is we go, okay, see I have a 2, a 2, and a 6. I could take out my common factor of 2 from my solution. There it is. Now what I'm going to do is, we didn't really want to divide out x minus 1/2. We really wanted to divide out 2x minus 1. So what I'm going to do is I'm going to reconstitute this by multiplying this 2 back inside. So that becomes that. This is still x squared plus x plus 3. This is still plus 2. The remainder doesn't change. So in this case, my quotient, my solution or answer, is this, and my remainder is 2. So if I were going to do this by synthetic division, okay, so 3x plus 2 is really going to be 3 times x plus 2/3. My 0, this is going to be x equals negative 2/3. So first, write out all my things. 6, negative 8, negative 5, 5. Negative 2/3 goes here. 6 drops down. Negative 2/3 times 6 is going to be negative 4. Negative 12. Negative 12 times negative 2/3 is going to be positive 8, if I've done that mental math correct. Again, that's a really big if, but I think it works out. Negative 5 plus 8 is positive 3. Negative 2/3 times positive 3 is going to be negative 2. Add down 3. So my remainder is 3. I can write this as, now, x plus 2/3 times 6x squared minus 12x plus 3 plus 3. I now take out my common factor, or basically the denominator I'm trying to get rid of. So I take out 3. This is going to be 3 times 2x squared minus 4x plus 1. I believe that's moderately correct. And this is still x plus 2/3. So now I can take this 3 into there, reconstitute this bracket back to its former glory. 2x squared minus 4x plus 1, all plus 3. So anyway, that's how that last piece works with that. Try it out, see if it makes sense. Other than that, you are good to go.